Hi, my name is Sean Hayden, and I'm the Executive Director of the Lake Waramaug Task Force.
Hi, my name is Kelsey Sudol, and I'm the research assistant for the task force.
Welcome to Lake Waramaug. We are here on Arrow Point, our task force facility, where we're doing everything we can to help the lake be clean, clear, and swimmable. And welcome to the Lake Waramaug Task Force. We are a organization focused on using science and data collected from the lake to do everything we can to minimize cyanobacteria and its negative impacts to Lake Waramaug. Historically, Lake Waramaug was clear, but signs of the lake's slow decline began in the 50s. The lake's eutrophication accelerated dramatically, and recreational activities in the lake were curtailed. Real estate values were plummeting, and the future of the lake did not look promising. At the low point, there was continuous algae blooms that left the lake so clouded and discolored that visibility was only 2 to 4 feet. The algae food sources were phosphorus in the lake's surface water. Uncontrolled runoff from farms, septic systems, lawns, houses, and roads in the lake's watershed area produced phosphorus levels that soared to over 30 parts per billion. In response to this crucial situation, the Lake Waramaug Task Force, founded in 75 by a group of concerned lake residents. Everything we do at the Lake Waramaug Task Force is making it uncomfortable for cyanobacteria to thrive. But I think what's most important is that you understand what cyanobacteria are and how they behave and why they are so toxic and dangerous to the lake.
You might have heard cyanobacteria called another name, which is blue-green algae. The interesting fact about them is that they are not actually algae, they're bacteria. They are the first photosynthetic organism that evolved over 2.7 billion years ago. And because of that, they've been around a very long time and they've evolved a lot. Cyanobacteria are in every natural water body there is, from wetlands to oceans to freshwater. And there are many, many different types of them. Saying cyanobacteria is kind of like saying something's a tree. It's a very broad range of organisms. So they've been around a long time and they are actually very important in ecosystems. Cyanobacteria come in many different shapes and sizes. On the screen now, you can see some examples of different types. Cyanobacteria are usually measured in what are called colonies, which are a collection of cyanobacteria cells. The one on the top left is called microcystis, and an analogy for its colony is think of a bag of toys, and each individual toy inside is a separate cell, but the entire bag works as one organism. The one to the right of that is Dolichospermum, and an analogy for that one is beads on a string like a bracelet. The one on the bottom is called Aphanizomenon, and analogy for that one is a handful of spaghetti, with each individual cell being its own piece of spaghetti, but the colony itself, the handful of spaghetti, works together as one unit. It is usually what you will see cyanobacteria measured in water quality. Its density is usually represented in colonies per milliliter. So, for example, in the state of Connecticut, if you see cyanobacteria levels posted at a beach that are above 100,000 colonies per milliliter, that typically means that the beach is closed for fear of a toxic algae bloom. There are many different toxins that are produced by cyanobacteria, and it is an area of study that is rapidly evolving. We don't very much understand the effects of them, or even how, for example, density relates to toxin levels. It's not a one to one relationship. They find that some species can have very high toxin production at very low densities, while others can have very toxic or look very toxic. For example, this bloom on screen right now could very well have absolutely no toxins in it. You have to test it in order to find out. And that really adds a level of complications to things when it comes to tracking and understanding these blooms, which a lot of lakes and different water bodies in Connecticut are dealing with. Another assumption, cyanobacteria blooms are specific just to lakes, but a lot of large rivers have started to have cyanobacteria problems. The Connecticut River specifically has been increasing their monitoring of cyanobacteria due to various blooms that have been popping up. Why are they a problem? They're a problem because, as you can see in this video, when you get very high densities of them, they create what's called a bloom. These blooms are often caused by humans. So, for example, high levels of nutrients can cause them to bloom, land use disturbance, etc. When we misuse our water resources, that can often result in these cyanobacteria blooms. Why we care is that they often are very toxic in these large blooms. There's a lot of research between exposure over your lifetime and people who have neurodegenerative diseases like ALS and Alzheimer's. In the short term, exposure to these blooms can cause rashes, it can cause gastrointestinal problems, it can cause flus. It is very toxic to a lot of different wildlife and pets. Every year, there are a certain number of animal, specifically dog deaths that happen because people let their dogs go into water, such as you see on screen. So everything we do at the task force is to fight against these toxic blooms, or another term you might hear is called HABs, or harmful algae blooms.
Here at the task force, we have a lot of projects going on, and most of them are focused on trying to combat favorable conditions for cyanobacteria growth. You'll be able to see all the things that we are doing at the task force in the following videos.